Hello, dear students. How are you? I hope you are doing good. I welcome you all in this session of question discussion about AIET NEET examination. In this session, we are going to discuss some questions that seems pretty tough to you, and we will solve them question here and see the concept behind. So, without wasting time, let's just get started with the first question. Now, here in the question, as you can see that velocity is given as a by t plus bt square, where symbols have their usual meaning, the dimension of A and B are respectively. So these types of questions from dimensional analysis you can see on a frequent basis. So how to solve this question? So first of all, we should write that velocity is given as this expression for you should write this. Now we can know that concept is the concept that we talked about. The concept that we are talking here is same dimension can be added or subtract. Okay. So सेम dimensions को ही हम add और subtract कर सकते हैं. So in this manner, if you see that velocity here is become a by t. Okay, velocity is a by t. Velocity here is given by a by t. We know the dimension of velocity is lt raised to the power minus 1. We don't know the dimension of a, so we will write it as this. And the dimension of time is capital T. Now, if you see from here, the dimension of is coming out as L. Okay. So by the option also you can eliminate. You can do the elimination method. Only in option A the L is mentioned, in nothing else. So we can choose this option also. In any other option there is no such answer matching to us. Okay. The only answer matching to option A. So we can choose this also. Otherwise you can solve this, but I would not recommend this to solve the complete questions, because if you find it out that only this, you find the dimension of A is L and L is mentioned only in option A. So just pick that. Okay. Now velocity has a dimension of Lt minus 1. Now you will compare it with B t square. Now the dimension of B will become Lt minus 3. And that will also verify your answer that option A is the correct one. Now move on to the next. A scooterist sees a bus 1 kilometer ahead of him, moving with a velocity of 10 meter per second. With what speed the scooterist should move so as to overtake the bus in 100 seconds. So let's say there is a bus here which move in this direction, let's say. Okay. And the scooterist is here. Here is the scooterist. Okay. So the distance initially between the bus and the scooterist is 1 kilometer. And since you can see the answer is meter per second, all the dimension are given in meter and second. So we'll convert this distance in meter. So it is 1000 meter. Okay. And the bus is moving with a velocity of 10 meter per second. So the velocity of bus is also given to us 10 meter per second. With what speed the scooter should move so as to overtake the bus in 100 seconds. So it's very obvious that scooters should move in the direction of the bus moving. And let's say it is moving with a absolute velocity v. Now we will assume that the velocity of scooterist with respect to bus is velocity of scooterist plus velocity of bus. And since these are in same direction, so we will be having a minus sign. So we can say it is v minus 10. This is the relative velocity. Now with this relative velocity, because we are measuring this distance with respect to bus, this velocity with respect to bus. So bus is in rest with us, and we have to cover only 1 kilometer distance with this velocity in 100 seconds. So we can say V is equals to S by T. V is V minus 10, S is 1000, and T is 100. So you can cancel out this, and velocity will become here 20 meter per second. So the velocity of scooter is should be 20 meter per second to catch the bus in 100 seconds. Now, the position time graph, xt graph, for a particle moving along x-axis is as shown. Average speed of the particle between t is equals to 0 to t is equals to 8 seconds. So we know that this is a position time graph. Area of position time graph gives us what? Position time graph. Area of position time graph gives us what? Distance or displacement. Okay. According to the situation. What? So here we want to calculate the average speed. So we will only talking about the distance. So you can calculate the area of these two triangles. This will be the distance traveled in 0 to 8 seconds. Now, distance traveled in 8 seconds is the area of triangle 1 and the area of triangle 2. Area of triangle 1 is 1 by 2 times base of the first triangle, which is 4, this one, and height of the triangle, which is 5. Similarly, for second triangle, the base is 4 again, 4 to 8 is 4, and the height is 10. Now, this will cancel out to, it is 10 plus 20, which gives you 30 meter. So 30 meter is the total distance traveled in 8 seconds. So average speed will become total distance traveled, total distance divided by total time taken. Okay. Total distance is 30 meter and total distance, total time taken is 8 seconds. So from here you can say it is 15 by 4, which is come out to be as 3.75 meter per second. Option C is the correct answer. Now, projectile is thrown with an initial velocity of AI cap plus BJ cap meter per second. If the range of the projectile is twice the maximum height reached by it, then since in this question, the velocity is given to us in vector form. The velocity vector is AI cap plus BJ. We can say that the x component of the velocity is A and the y component of the velocity is B. Now, I'll introduce range and height in terms of Vx and Vy. So range ko you can also write 2 times of Ux Uy upon G, and height also you can write Uy whole square by. Now in the question that there is a condition given to us, the range of the projectile is twice, which means R is equals to 2 times of H. From this equation, if you put the value of R and H in this way, here, R is 2 times of Ux Uy divided by G, and this will become Uy by Uy square by 2G. This G and G will cancel out each other. Uy and Uy cancel out. So only remaining thing is 2Ux is equals to Uy by 2. Okay. Now, if you put the value of Ux and Uy from this equation, what you will have here? 2 times of Ux, which means A, is equals to B by 2. So we can say that B is equals to 4A. This is the condition when range is the twice of maximum height. Now, A body is projected at an angle of 30 degree to the horizontal with a speed of 30 meter per second. What is the angle with the horizontal after 1.5 seconds? In the projectile motion, if you say, in the projectile motion, let's say this is the velocity. The angle at any instant, let's say this is alpha, is given by tan alpha is equals to Vy over Ux, Vy over Vx, the component ratio of the velocity at that particular time. Now, if you just solve this question, here in the projectile motion, we know that horizontal component of the velocity remains constant throughout the motion. Okay, so this ux will remain same, but uy will change because of the effect of gravitational force. So we will wish to calculate vy at 1.5 seconds. So vy will become uy plus ay into t. Vy is equals to uy minus g into t, which can also be written as vy is equals to uy. Uy is u sine theta, which is 30 sine 30. Sine 30 is 1 by 2 minus 10 into 1.5. 1.5 the time at which we are calculating the final velocity. This will be 15 and this will also 15. 15 minus 15 is 0, which means at that particular 1.5 second, the projectile at the maximum height. So at the maximum height, the velocity is parallel to the x-axis. So angle will be 0 degree. This option is correct. Option is A. Now in this question, this is the pure vector analysis here. If modulus of A vector cross B vector is equals to root 3 times of A vector dot B vector, then what is the value of A vector plus B vector का modulus? Very easy question. Now in this question, just use this equation. Magnitude of a dot cross product is AB sine theta, and the magnitude of cross product is AB cos theta. Okay, now this AB and AB will cancel out. Sine theta by cos theta gives you tan theta equals to root 3. So theta will be coming out as 60 degree because root 3 is the value of tan 60. Now it's asking for A plus B, magnitude of A plus B, which is given by A square plus B square plus 2AB cos theta. A square plus B square plus 2AB cos 60 is 1 by 2. This will cancel out, so we can write it as A square plus B square plus AB raised to the power 1 by 2. Option B is the correct option in this question. Move on to the next one. The velocity of river flow is 6 km per hour, in which a boat has speed 10 km per hour with respect to the still water. With respect to still water means the velocity of boat is absolute velocity of the boat. Time taken by the boat to cross the river of 2 km wide through the shortest path is, now let's say this is the river and it is flowing in this direction, let's say, with a velocity of 6 km per hour. Now the velocity of boat VB is given as 10 km per hour. But when the boat move inside the river, on the river, the velocity is with respect to the river flow. So if one has to travel to the shortest path, this is the perpendicular path over the two banks. This is the shortest path. This is the width of the river, 2 kilometers. So the velocity of boat with respect to river should be perpendicular, okay, to the river flow. Now in this case, if this is to be velocity of boat is given by 10 kilometer per hour, velocity of river is given by 6 kilometer per hour. Now VBR is perpendicular to the river flow. As one method, you can say that this is VB. So VB and this is VR. You can take the component of this will be perpendicular. Okay. Let's say this angle is theta between VB and VR. And the angle between VBR and VR is 90 degrees. Okay. Clear? So here we can say that VBR is VB plus VR, relative velocity concept. Okay. Now from this equation, the time taken by to cross the river is through the shortest path is S upon B, VR. Now S is what? 2 kilometer divided by VBR is what? 10 plus 6. 10 minus 6. They can be minus. Okay. 2 upon 10 minus 6 will become 4. It has become half. And this will become, this is half hour, which is 30 minutes. Okay. Now, the position coordinate at a projectile thrown from ground are given by y is equals to 3t minus 5t square and x is equals to 4t. Horizontal range of the projectile is. Very conceptual question. So here y and x coordinate given in terms of time. 3t minus 5t square. Now y is equals to 3t minus 5t square and x is equals to 4t. We know that projectile motion will be like this. So at the starting of the projectile motion and at the end of projectile motion, the vertical height covered by the projectile is 0. So we can say that the time taken we can calculate when y will become 0. So to calculate time, we putting y is equals to 0, 3t minus 5t square. You can take t common, so it will become 3 minus 5t equals to 0. Now t is equals to 0 and t is equals to 5 by 3. It is verifying our condition that at the starting of the motion, the vertical height is 0 and at 5 by 3 second, the vertical height is 0. Now to calculate the range, we only need the velocity in x direction. So for that, dx by dt you have to calculate, which is 4 meter per second. Now, range would be ux into ux is 4, time is 5 by 3. So it will be coming out as 20 by 3. This will be the range of the projectile because the velocity in x direction is 4 meter per second and the time taken by the projectile to again reach at the lowest point of the journey is 5 by 3 seconds. Sorry, this is not 5 by 3, this is 3 by 5. 3 by 5. Now when you put it here, 3 by 5. So it is coming out to be as, just a second, I'll just recalculate it again. T is equals to 0. And 3 minus 5t is equals to 0. 5t is equals to 3. So t will be 3 upon 5. Now this is the x coordinate, x is equals to 40. And simply this is the range of projectile. So you put the time here. X is equals to 4 into t. 4 into time is 3 by 5. 4 through is 12 by 5. So it is 2.4 meter. Okay. Now, a cart is moving horizontally along a straight line with a constant speed of 30 meter per second. A projectile is to be fired from the moving cart in such a way that it will return to the cart at the same point on the cart. After the cart has moved 80 meter, at what velocity relative to the cart must projectile be fired? So here the situation, let's say this is the cart over here. A projectile thrower is placed at the top of it. And now the cart has moved 80 meter. So let's say this projectile is fired upward with respect to the cart. Okay. It also have a horizontal velocity. If you see at the ground frame, because this projectile is moving with the cart. So whatever the initial velocity cart has, same will transfer to the projectile. So we just have to add a vertical component of velocity over it. So the projectile must be fired in vertical direction so that it will have a velocity like this. And it will cover the same distance in the horizontal direction as the same as the cart. Now, distance covered by the cart is, let's say, 80 meter, which is given in the question also. And the horizontal component of the projectile motion, same as the velocity of cart, 30 meter per second is given to us. Okay. So to cover this distance with a speed of 30 meter per second, because in horizontal direction, there is no force. So we can say that time taken to cover this 80 meter is R is equals to, just a second, time taken is R by U. R is 80 meter, U is 30 meter per second. So time taken is 8 by 3 meter per, second only. Now what is the vertical component of the velocity? Only vertical velocities need to be given to the projectile. Okay. So what should be that particular velocity to cover the same range over here? So for that, we will apply the equation Vy is equals to Uy plus Ay into, we can apply this equation. Vy square is equals to Uy square plus 2As. Okay. The horizontal range is 0 over here. So from that equation, we can also say that Vy at the initial and at the final will be same. Got it? Now, this particular projectile has to return to the cart, which means it is also having a range of 80 meter. So we can say that the range of projectile is given by 2 times of ux into uy divided by g. Range is 80 meter. Ux we have already calculated, which is 30. Uy we need to calculate divided by 10. This and this will cancel out. 2 4 ja 8 and Vy will become 40 by 3 meter per second. So this velocity we need to give to the projectile so that it will return to the cart at same point. Now this question, a particle of mass m is moving in a horizontal circle of radius r under centripetal force equals to minus k by r square, where k is a constant, the total energy of the particle is. The force given to us here is minus k by r square. Now since this force is categorized as centripetal force, so we can say that centripetal force is nothing but mv square upon r, where r is the radius of the circle. Since r is given in small letter, so we will mention it as a small letter, mv square upon r, and it is nothing but equals to k upon r square. Now from this equation you can say that mv square is equals to minus k upon small r. If you multiply by half, this is the kinetic energy of the system, which is minus k upon 2r. Now we need to calculate the potential energy. We know that potential energy is nothing but minus of f dot ds or dx, negative of work done by the conservative force. Okay. Now there is no reference given to us here, so we'll take a reference of infinity to small r. Okay. So you will become minus infinity to small r. F dot dx is f expression we know, minus k upon r square into dr. So we'll take dr as this. Okay. Minus, if you just integrate it, will become minus and minus will become plus because it's already minus here. K upon k can also taken as outside because k is a constant quantity. 1 upon r square will become r raised to the power minus 2 plus 1 minus 2 plus 1 infinity to r. K into this will become minus 1 upon r infinity to r. 1 upon infinity will be 0. So it is coming out to be as minus k upon r. Now, why we have taken infinity? Because at infinity, the potential energy is 0. Okay. So if you calculate the total energy here, total energy would be minus k upon 2r minus k upon r. So when you are talking about the delta u, na, this minus must be vanished because we are calculating it from infinity. So infinity to r, infinity plus 0, and at r it had some value. So that is why we can take it positive. When you do so here, the minus will vanish out and this minus and minus will be plus here. This would be plus. Okay. So this plus k by r minus k by 2r, so it will become minus k upon. This is the total energy. Option C is the correct. No. Two blocks of mass 10 kg and 5 kg are connected with a light string which passing over an ideal pulley attached with a fixed smooth base. If the system is released from rest, then the acceleration of the block will be. So here if I draw the forces on this block, let's say this is 10 kg. So the weight of this block acting downward, tension will be developed. The same tension will be developed over here also. Okay. Because this pulley is ideal. So in that case, if this pulley is ideal, the tension on both the side of the pulley will be remain same. Okay. And the acceleration of the block is also same. Now, here the tension is same. Okay. So here we have a block of 10 kg. The weight of the block is acting downward. Tension is distributed same because the pulley is ideal and the string attached to it is very light as mentioned in the question. Okay. So if I draw the FPD of this 10 kg block, the weight is 10 kg acting downward, tension up. Since this block has weight more than the another block, so this blocks try to pull the another block in the downward direction. So it has an acceleration in this. So if I apply the Newton's second law here, it will be 10g minus t is equals to mass of the block, which is 10, into acceleration. The blue, this pulley is smooth, so the acceleration of this block is also a yes. So if I draw the FBD for the another block, which is 5 kg, so you can see here the weight is acting downward, which is 5g. This is 5g cos theta, this component, and this component will be 5g sine theta. Theta is 37 given to us, sine 37 is 3 by 5. 3 by 5. So if I apply the equation here, the tension is developed here on this axis, on this way. So it will be T minus 5g sine 37 is 3 by 5 is equals to 5 into A. This is equation 2. If you add these two equations, this tension and tension will cancel out. So it is coming out to be as 10g minus 3g is equals to 15A. Now 10g minus 3g will be 7g is equals to A. Now g is 10. So you can put the value of g here. 7 into 10 divided by 15. 5 3s are 15, 5 2s are 10. It is coming out to be as 14 by 3 meter per second square. Option D is the correct option. Okay. Now move to the next. In the arrangement shown in the figure, all the features are smooth. String and pulley are light. Find the tension in the string. So the same way, tension will be same because the string is light. Okay. Pulley is smooth. Acceleration must be same. Here, if you draw the weight, which is 2g, this component will be 2g cos theta, and this component will be 2g sin theta. Now the same here also, this is the weight 2g. This component will be 2g cos theta, same, and this component will be 2g sin theta, which means this component is pulling the block in the downward direction, and in this way, this is also pulling the block in the downward direction. Now, which blocks pull which block? That is the question also. If you calculate this force on A, which is 2g sin theta, so for that, theta will be theta 1, let's say, because both the angle are not equal. So 2g sin 53 will become 4 by 5, which is 8g by 5. And for block B, it is 2g sin theta sin 37, which is 2 times of g into 3 by 5. And this ultimately gives you 6g5. So you can say that clearly the force which is acting on block A is greater than the force which is acting on block B. So block A will pull the block B in this way. Apply the Newton's equation. So we can say that on block A, 8g by 5 is the in the direction of acceleration. So it is taken to be positive. Minus t is equals to 2 times of A. This is equation 1. For second equation, t minus 6g by 5 is equals to 2 times of A. This is equation 2. Now add up these two equations, you will have 8g by 5 minus 6g by 5, it is 2g by 5 equals to 4a. 2 to the 4, and this acceleration is g by 10, which is 1 meter per second square. Now we have to calculate the value of tension, so you can put it the easier calculation. T is equals to 6G by 5 plus 2. Now this G will cancel out 2 times. 6 to the 12 plus 2 will be 14 Newton. So tension in the string will be 14 Newton. Now this one, a light string is going over a clamped pulley of mass M supports a block of mass capital M. As shown in the figure, the force on the pulley by the clamp is given. This is a very interesting question, by the way. Here is the pulley weight we have. Here is the weight M of capital M. And here the weight of pulley is also mentioned, which is also acting downward. But the weight of the pulley is not creating any tension in the string. Okay, for now. Because it's just having a support with this. This string is only supporting this block. Okay. So we can say that here tension is equals to capital M into G. But if you talk about the net forces, it will be on the clamp. If you will see, this is the tension. This is capital Mg. And there is one more force, which is small mg. Small mg is the force of weight of pulley. So if you take the resultant of it, that resultant force will be resisted by the clamp. That is why the pulley is not moving here and there. So the resistance force in these two forces are in perpendicular direction. So we can say that R, which is the resultant force, is the square root of force 1 ka square plus force 2 square. Let's say T square plus, and the second force is capital M G small mg whole square. Now tension is equals to what? We have seen here capital Mg whole square mg plus small mg whole square. You can take g common, and outside the square root, it will be coming out as capital M square capital M plus small m whole square. This is the force on the clamp. Option D is the correct. Now this one, a particle is moving in a circle of radius r under action of force alpha F is equals to alpha r square, which is directed towards the center of the circle. Total mechanical energy, kinetic plus potential of the particle is. So the same question that we have solved just a few questions before. F is equals to alpha r square mv square upon small r alpha r square. 1 by 2 mv square will become alpha 1 by 2 alpha r cube. So this is the kinetic energy, and for potential energy again, you can differentiate it with f dot dx or dr with, here take potential energy 0 for r is equals to 0. So limits are be 0 to small r. So you can apply here and then calculate the force over the, and calculate the kinetic energy plus potential energy of the system. Okay. Now move on to the next one. This. A rough vertical board has an acceleration A along the horizontal so that the block of mass M pressing against it does not fall. The coefficient of friction between the block and the board is. So if you are sitting on this, for you this particular block is in non-inertial frame. Non-inertial frame. And in non-inertial frame, we will apply the what? We will apply the pseudo force, because this whole system is accelerated. So that is why we have to apply the pseudo force to counteract this. If you will see the video of capital M block, there is a pseudo force acting in the opposite direction of the system is moving. And it will be equals to mass of the block, acceleration of the system. And there is a normal reaction on the block. There is a force mg which is acting downward, and the coefficient of friction will be acting, or the frictional force will be acting in the opposite direction, because this particular block is trying to move in the downward direction. So we can say that F is equals to what? F is equals to capital M into G. F is equals to N mu into N. So we can say mu N is equals to capital M into G. Mu capital M into A is equals to capital M into G. So this capital M and capital M will cancel out. So mu is coming out to be a G by E. So this force is that we have equate with the frictional force is the limiting force. And the force of friction is always less than or equals to the limiting force, which means this mu that we have calculated, if you are putting the value over here, which is FL is mu into N, is greater than equals to capital M into G. M and M will cancel out, so mu is greater than G by A. So this mu must be greater than G by A to resist the block moving downward. Option D is the correct. Now this one, a body slides down the track from point A as shown in figure, maximum value of R that a body to complete the loop successfully. So we know that to complete the loop successfully, the velocity at the bottom point should be root 5G. L is the length of the string, but here the loop is given, so you will stay 5G R. So we can apply the kinetic energy, mechanical energy conservation between point A to point B. So K initial plus U initial is equals to K final plus U final. K initial is 0 because this block is just released from this point. So initial velocity is 0. Initial potential energy is mg into h. H is 5 into 10 raised to the power minus 2. Converting it into meter. Kinetic energy finally is 1 by 2 mv square plus potential energy finally is 0. We are taking reference here. So m and m will also cancel out here. This will become 5 into 10 raised to the power minus 2 into g into 2 is equals to v square. So here you can take the value of g is 10 and 5 to the 10 also. So we will become 1 meter per second. This is the velocity. You should equate this velocity with root 5 gr. 1 taking square of both sides, it is 5g into r. R will become 1 upon 5 into g. Now this is in meter, so converting it into centimeter, this will give you 5 to the 20, 5 to the 10, and g is having a value of 10, so it is 2 centimeters. So radius of the loop must be 2 centimeter. Option is the correct. Now this one, if a variable conservative force acts on a block of mass 2 kg initially at rest shown by a graph, then speed after moving 4 meters is. In this graph, you can say this is the force displacement graph. This is the force displacement graph. Force displacement graph का area gives you what? Work done. And work done को you can equate with the applying work energy theorem. It will be 1 by 2 mv square. Kinetic energy. From there you can find out the velocity. But to calculate, how to calculate the area of these types of graph? This is not a circle because here to here it is 2 and here to here it is 10. So the area of these types of curve is pi r1r. Okay. Or pi by 4 d1 d. So area is pi r1 by r2, which is work done. Pi r1 is what? 2 and 10. Work done 1 by 2 times m v square pi into 2 into 10. This will become, what is the mass of the block? It is 2 kg, 2 and 2 will cancel out. So v square will become square root of 25 meter per second. This is the velocity. This is how you are going to calculate. Thank you so much guys for this session. Now, if you have any kind of doubts other than these questions, you can connect to me over the regular classes. I hope that you would enjoy this session. Thank you so much. Bye. Take care.